Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host, as usual, is Tobias Macy, and today I'm interviewing Robert Nishihara about his work at Anyscale and the RAID distributed execution framework. So, Robert, welcome back. And for the folks who haven't listened to the previous episode that you did, can you give a brief introduction?
Yes, I will, and thank you so much for having me here. So I'm Robert. I'm one of the co-founders and CEO of Anyscale, and also one of the creators of Ray, which is an open source project that we created to make distributed computing easy and to make it easy to scale and productionize AI applications. Before starting this company, I did a PhD in machine learning at UC Berkeley, and that's actually some of the challenges we ran into, doing machine learning research are what motivated us to really start Ray, and that's how all this got started.
And do you remember how you first got introduced to Python?
Yes. I had previously been doing machine learning research as an undergrad in college, and we were all using MATLAB to, do sampling and other machine learning algorithms. And that was right around the time where deep learning was starting to take off and everyone just started transitioning to Python at around 2012.
In terms of the Ray project, as I mentioned, you've been on the show before. We did a pretty deep dive into the technical underpinnings of that project and some of its history. But it was right around the time that you and your co-founders were building the Anyscale company to help support that project and grow its ecosystem. I'm wondering if you can describe a bit about what it is that you're building at Anyscale and some of the story behind how you decided to turn that into a business and why you wanted to spend your time and energy focused on this particular problem space.
Let me start with why we started Ray and then why it made sense to turn that into a company. Like I mentioned, my co-founders and we were doing machine learning and machine learning research at Berkeley. And one of the challenges that we were running into over and over was just that in order to do machine learning, there's often a huge infrastructure investment. You're often spending a lot of time on the, distributed systems engineering or, low-level systems engineering to speed things up or to scale things up. And that requires a ton of expertise. It's super hard, right? So you have all these people trying to do machine learning who end up going on this detour and gaining all of this expertise in distributed systems and infrastructure just so they can build the tools they need to do machine learning. That's incredibly costly. It's expensive. It's hard. We felt there was an opportunity. We were going through this, and as well as tons of other people around us, and we were all kind of doing it independently. And we realized, there's an opportunity here to build significantly better tools. If we can build tools that sort of take care of all of this infrastructure work for you and make it easy, then that could potentially, really accelerate progress in machine learning and just enable developers to be much more productive. So we started Ray as an open source project to try to do that. We had no ambitions to start a company. I think if you asked us at the time whether we would start a company, we probably would have been fairly dismissive of the idea. And our focus was on making the open source project useful for people. We started working on it, trying to grow the project, get more users. We were running around Berkeley trying to get our friends to try it out and, watching over their shoulders as they installed it and started using it. Of course, they'd run into issues, and then we try to, debug those issues on the fly and get them to try it out again. And this evolved over time. All at Berkeley, we were running boot camps, running tutorials to train people how to use Ray. We started collaborating with companies that were using Ray in production, giving talks, and running training sessions. As the project started to take off, we ended up, asking ourselves, what would it take to really solve this problem and really try to, build something super useful here? And I think to take something, all the way to where it's really something that companies and everybody can rely on in production, and that's a part of the infrastructure that companies are relying on for their mission critical workloads and everything. It's a long journey, right? There's a lot of energy that needs to go into that, a lot of effort that needs to go into hardening and productionizing things. And of course, we felt this was an important problem. More and more applications were becoming distributed. AI, has the potential to really just reshape every industry, but it's hard because of the infrastructure investment. That's one of the things making that difficult. And so if you ask, what will it take to really enable just every organization to succeed with AI, to get value out of AI, and how do we, solve that infrastructure challenge for companies so they can succeed with AI? That is something where we weren't going to be able to achieve all of this with just a few grad students working together at Berkeley. We really needed to be able to move much more quickly and put much more energy behind it. That led us to start the company. So basically, we started the company because we felt it was an important problem, right? That everything's becoming distributed. Distributed computing is hard and is necessary for doing AI. At the same time, we thought it was a timely problem, right? This was happening all around us. And the open source, Ray was taking off. We had a group of people that were working really well together. And we, managed to convince ourselves that it could make sense as a business in addition to all of that. So those are some of the factors that we were thinking through and that led us to start the company.
And in the couple of years since you were on the podcast last and the couple of years of building and growing the Anyscale business, I'm wondering if you can talk to some of the particular areas of focus and ways that the project and the business have evolved or changed and ways that the ecosystem has grown up around them both.
Yeah, absolutely. So let me start with Ray. What's changed with Ray? What's new with how we think about Ray? So Ray really has two parts to it. There's the core, underlying distributed system, which is fairly low level. It lets you take regular Python code built out of functions, Python classes, and to kind of translate those into the distributed setting so that you can take pretty much an arbitrary Python application and find a way to scale it. So it's super general, super flexible, but it is fairly low level, right? So if you want to build powerful applications on top of the core Ray system, you can do it, but you have to build a lot of stuff. So the second part of Ray is on top of this core system, there's an ecosystem of libraries. And, they're higher level tools. They're easier to use. They just work off the shelf, right? This could be for, scaling deep learning training. It could be for scaling, your hyperparameter tuning and machine learning experimentation. It could be for your data loading and pre-processing right before you do the training. It could be for deploying the models. It could be for reinforcement learning. There are many libraries like this you can use and scale on top of Ray. One of the things that's most notable over the past couple of years is this shift in focus to really emphasize the library ecosystem and really to try to create the best possible ecosystem of scalable libraries on top of Ray. And the reason this is important for us is there's two reasons. One is that the libraries are just easier to use, because a lot of logic is already built that you don't have to rebuild. There's an analogy there with Python, right? Python, itself is very general, fairly low level. And then on top of Python, you have a bunch of great libraries like pandas and NumPy and so on. And of course, a lot of the value in Python comes from the library ecosystem. And we think the same thing will be true in the distributed setting. That's one reason. It makes it easier to use for users. The second thing is that there's this network effect where a lot of the value of a given library comes from the fact that you can use it along with the rest of the ecosystem. So maybe I want to do training. I want to train my model, say my TensorFlow model, and I want to scale that. But chances are, in order to do that, I'm also going to need to load some data, maybe transform that data as it's being fed into the training. And then maybe I'm going to want to, as I'm training the model, I'm going to want to train multiple models and do this like hyperparameter search experimentation. And then maybe I'm going to want to take that model that I trained and deploy it, serve it in production. Without Ray, each of these steps would be a separate distributed system. And with Ray, this whole end-to-end thing can just be a Python script. And so, as we build this ecosystem, every new library is going to add value for all of the users of the existing libraries. And so that's something we've really tried to double down. And as far as, how we're thinking about Ray, that's something we're super excited about.
And to your point, each of those different pieces being its own distributed system. One of the things that came to mind is the Horovod project that was spawned out of Uber and has been adopted by the community. And I'm curious what you see as the overlap from projects such as Horovod and the capabilities of Ray, and maybe ways that the two can operate in concert.
That's a fantastic question. So Uber created Horovod to be able to scale deep learning training. Uber has been, using Horovod to train their deep learning models. Now, the interesting thing there is that it's not a Ray or Horovod kind of question. And Uber is now today training Horovod models on top of Ray, right? Scaling the training with Ray. And given that they already had something working, why port Horovod to run on top of Ray, when you already have something working? Well, the value there for them, there were sort of two benefits. One, like I mentioned, was integration with the rest of the ecosystem. So there's the potential to use Horovod along with the other libraries, whether that's for data ingest or hyperparameter tuning and whatnot. The second thing, though, is that when you build a library on top of Ray, you inherit a lot of the benefits of Ray. Ray solves a lot of distributed systems challenges, whether that's elasticity, auto-scaling, fault tolerance, scheduling, things like that. And so when they were deploying Horovod on top of Ray, they inherit that elasticity, the fault tolerance, and things like that. And so that is, one of the reasons we see libraries, developers scaling these libraries and sort of integrating them as part of the Ray ecosystem. And the same thing is true with libraries like XGBoost and other popular libraries as well.
Yeah, I know that another library that is taking advantage of the Ray ecosystem is Modin, to be able to abstract the distributed capabilities and be able to just provide that pandas interface to be able to scale from local to distributed compute.
That's absolutely right. You can run Modin on top of Ray to scale pandas. You can run Dask on top of Ray to scale the, Dask data frames, Dask arrays, and things like that. There's also Ray datasets, which are a library for data loading and preprocessing for training.
Yeah, I was going to ask about Dask because I know that last time we spoke, I asked about it, and they are the two frameworks that are widely viewed as the way to scale out your Python compute. So it's interesting to see that Dask is now being available as an API layer on top of Ray as the underlying engine.
Yeah, in a lot of ways. And Dask has great libraries for data frames and arrays and data sets and things like that. And you can use those together with Ray's libraries for machine learning, and use them together and to build a single application. And it all runs on top of Ray.
And as you mentioned, the overall space of machine learning and AI has exploded in the past decade with the widespread adoption of deep learning. And even in the past couple of years, there has been a lot of activity in terms of new model types, new approaches to transform learning. And I know that one of the areas of focus for Ray in particular is the space of reinforcement learning. I'm just wondering if you can talk to some of the ways that the overall landscape of AI and ML technologies has shifted and evolved over the past couple of years, and some of the ways that you are looking to take advantage of that evolution with the Ray engine, and some of the ways that you're supporting that transformation in the space.
Reinforcement learning is a good example of this. The way that a lot of people do machine learning today is that you have two distinct stages where there's the model development, you train the model, and then there's a handoff and it's put in production and served, right? And so what we are seeing is that more and more you're going to close the loop. Basically, you're going to have machine learning models that are interacting with the world, making decisions, taking actions, getting feedback, and then learning based on that experience, right? And so this is something we've seen companies do very successfully in the context of recommendation systems. We've seen it in other domains as well. And, reinforcement learning is one sort of formulation of this. Online learning is another sort of way to formulate this. The fact that Ray supports, you can do the deployment, you can do the serving on top of Ray, you can do the training on top of Ray, you can potentially do the data processing or streaming on top of Ray. As that emerges more and more as a sort of, standard way to do machine learning, that Ray will be really well positioned to support these kinds of online learning and reinforcement learning use cases. One thing I've been impressed with is the number of reinforcement learning success stories that I've seen at companies. We're actually hosting a conference, like a one-day summit on production reinforcement learning, end of next month, or actually end of this month, and to really highlight some of these use cases. But you see people doing this successfully in the gaming industry. You see people doing this for recommendations. You see people doing this for like controlling machinery and like industrial applications. And that's something that, if you can get it right, reinforcement learning can be applied very broadly and to a lot of problems.
When organizations and teams are trying to adopt and apply machine learning and AI capabilities to their products and their organizations, what are some of the common challenges and issues that they encounter when they're trying to move from initial prototypes into a production environment?
There are a few big challenges that stand out to me. One is about scaling. And this is really a lot of our just bread and butter with Ray and Anyscale. But the amount of compute required to do machine learning, you've probably seen these plots, is just growing incredibly quickly. It's not just reinforcement learning and things like AlphaGo. It's also, large language models or large computer vision models. It's all over the place. To do machine learning seriously, depending on the domain, you often have no choice but to scale things. And when I say scale, I mean, across many machines, perhaps in the cloud. And the problem, of course, is that scaling these applications requires that there's a big infrastructure investment. You're often building an infrastructure team and then relying on teams to maintain and manage these kinds of platforms for scaling. And so that is an area where one of the core motivations for what we're building, with Anyscale, is to try to take that infrastructure investment off of the critical path for doing AI. But of course, that is a big challenge today. And often we see, if they're evaluating using Ray or Anyscale, the alternative is often building their own distributed systems. So the first challenge around scaling, you can think of that as, like, I know how to do stuff on my laptop, but how do I really go from my laptop to the cloud? Right? How do I make that a coherent, a kind of a seamless experience? The second one is about not going from the laptop to the cloud, but really it's about productionization, right? It's going from prototype to production or development to production. And there, in many companies, that might be a handoff to a different team. It might be a different software stack. It might be a rewrite of everything. And so can you enable the same people who are developing and prototyping to also put stuff in production and to do that easily and potentially without relying on other teams? And there's a lot more considerations around production, whether that's monitoring, observability, just requirements like high availability and having SLAs and things like that, which don't come up during development. And that is, again, one of the main things we're trying to solve with Anyscale. So two of the main things we're trying to solve with Anyscale are about making it easy to scale from your laptop to the cloud, and then making it easy to go from development to production. So instead of being a rewrite when you go from development to production, really one is just a sort of an extension of the other. The third challenge, which is related to all of this, is just the expertise required to do all of this, whether that is expertise in infrastructure for scaling and production and things like that.
Along with the productionization and the utility of reinforcement learning, it also requires generally a real-time feed of data, being able to continuously execute that training and feedback loop in real time. And I'm wondering, what are some of the additional challenges that are brought about by trying to manage that real-time machine learning flow beyond just the kind of batch-based model development and deployment?
So there are many challenges around data. As a company and with Ray, we are very focused on the compute side of the story. And so, our customers or Ray users, their data may live in Databricks, or their data may live in Snowflake, or, in S3. There are a variety of different options that we integrate with there. And so, fortunately, we don't have to solve everything, but, we integrate with all of these different tools. But some of the challenges that people see are, the usual challenges you might expect around scaling, around performance. Some of these challenges we do have to solve ourselves because they're so tightly intermixed with, the rest of the application. So for example, say you're doing training, but as you're doing the training or between training epochs, you want to shuffle your data. That may be a common thing to do. And if your data is hundreds of terabytes or petabytes of data, having a system like Ray, which can potentially, perform that kind of scalable shuffle along with being able to do the training is super valuable. So that's one of the challenges. I think balancing that also with the real-time and streaming nature of a lot of applications, right? Being able to do serving and respond to queries or in a very low latency setting, that's another challenge. And there are a variety of things like that.
Particularly in the deep learning space, I know that another one of the concerns that a lot of organizations are dealing with is particularly recently, the general availability of GPUs for being able to do fast and heavyweight computation for model training, but also in order to maybe circumvent some of that, being able to do network pruning to scale down the number of connections and nodes within the model so that you can actually run it on CPUs at high speed. And I'm wondering how much of that applies to the reinforcement learning space as well, and just some of the work that you and your team have seen, or some of the ways that the community has been orienting around being able to improve the overall efficiency of executing these machine learning models, and maybe some of the ways that Ray is able to contribute to some of that network optimization in the models themselves.
So there's a few things there to touch on. One is that a lot of this work on, things like model pruning or, making like performance optimizations for neural networks, a lot of the work being done there is being done in the deep learning frameworks themselves, whether that is TensorFlow or PyTorch or JAX or things like other tools. And so because Ray integrates and is compatible with all of these different frameworks, we inherit the benefits of all of these things. So if somebody comes up with a way to discretize your neural net weights or, prune the neural network, to improve the performance, then you can scale that with Ray, or you can serve it with Ray, you do training with Ray, and, Ray will handle all of the kind of like distributed computing aspects of it, but you sort of get the benefits of all of these things together. So, a lot of the focus of Ray is on the infrastructure and sort of the compute layer, and then we integrate with all of the other, tools that everyone is building. But we do see that come up, certainly with training. It's a common theme to see, a lot of these training algorithms are bottlenecked by communication between the machines. And that's an area where one of the things we make sure to do is to have all of the latest and, best algorithms in the Ray training libraries so that we can get all of the benefits of the, advances that are coming out from other frameworks. The other thing I want to touch on there, you mentioned like accelerators like GPUs. As you know, GPUs are essential for doing deep learning. And you're going to see more and more of these kinds of accelerators. It's not just GPUs, it's TPUs, and there will be other, specialized accelerators coming out as well. This is super complementary with what we're doing with Ray, because the experience that we want people to have is, you can just define your neural network, or you can just define your application logic. That's all you have to worry about. And then you can run that with Ray or with Anyscale. And if you want to use a TPU or a GPU, you can just sort of say that you want 8 GPUs or say that you want, 4 TPUs. And those resources will just appear, right, in kind of a serverless fashion. They just are added to the resources, are just added to the cluster. And then your code runs on them and can take advantage of them. You didn't have to, install CUDA or whatever on all the machines, get the right AMI, figure out which instance type to choose, and then, figure out how to place your code there. All you really did was write your Python logic. And so that's the experience we want for people, just this, as if you have this infinite machine with all the possible accelerators on it, and you just say, this training task uses 8 GPUs. And then when it's done, the GPUs go away. And if you need 100 GPUs, they just appear. That's the kind of experience we want for developers.
On that note, I'm wondering if you can talk to some of the operational characteristics of deploying and managing a Ray environment and some of the complexities that are associated with just that productionization of Ray as an infrastructure component.
If you're using Ray, Anyscale should be the best way to run Ray, right? So maybe I didn't say this earlier, but Anyscale is providing a managed Ray service, right? So if you don't want to be in the business of managing infrastructure, then Anyscale can be a good choice. Of course, you can always run Ray yourself. And one of the things that people love about Ray is just how you can run it anywhere, right? Whether that is on your laptop, on any cloud provider, on a Kubernetes cluster. And the way you would deploy Ray on Kubernetes is similar to how you might deploy other distributed frameworks like Spark on top of Kubernetes. We have a Kubernetes operator that people find useful. But of course, a lot of the value, and what people like about Anyscale are, the way in which we make production easier and make some of these operational considerations easier, whether that is providing, monitoring out of the box, dashboards, and things like that.
As somebody who is providing the infrastructure and providing the managed experience for Ray to your end users, I'm wondering what are some of the specialized utilities and additional capabilities that you've had to develop to be able to manage those environments and being able to scale them and handle multi-tenancy and trying to optimize the performance and experience of end users who just want to use the Ray API, get their work done, and not have to worry about all of the underlying machines that are actually doing the compute.
So there are many, many things we've had to think about. Since you mentioned multi-tenancy, one thing I'll add there that we think a lot about is security, right? And, people always talk about, if you think about remote code execution, we are running arbitrary code from our customers and users, right? So isolation is something we think about a lot, right? And generally really invested from very early on in the company in building a strong security team. So that's one of the considerations. A lot of what we've built and things we've tried to do to make it easier, to add value for our customers, it's not just about developing Ray, but about developing some of the things adjacent to Ray. So for instance, one thing we give a lot of thought to is how to make deployment easy, how to let people build the right environments and deploy their applications in that environment in a reproducible way and a deterministic way, in a way that is easy to specify and you don't have to go deep into, building Docker images or things like that. So you can think about the kind of build farm infrastructure around that's been important. And some of the things we've been building are around collaboration, around giving organizations more insight into costs and being able to control those costs. And then, of course, the monitoring and production side of the story as well.
In your experience of running Ray in this production context at such scale that's beyond what most people are going to have to deal with, I'm wondering what are some of the sharp edges that you ran into in the Ray project that you've had to smooth over, and just some of the ways that the work at Anyscale has fed back into the open source?
I mean, at Anyscale, we are, developing Ray very heavily. A lot of our engineering effort goes into trying to make Ray really good. We always run into limitations of Ray, whether that is around pushing the limits of scalability. I think one of the big efforts is around, like I mentioned, making production easier. A lot of the requirements around production and deployments have really influenced, how we think about the Ray roadmap. And performance as well. I think there are a lot of requirements around just making things faster or making things perform better that we've done a lot of work there as well.
And on the note of the balance between the open source and the corporate work that you're doing, I'm curious if you can talk to the governance model around the Ray project and some of the ways that you think about sustainability of the project and the ecosystem, and how you think about the dividing lines about what to make commercial and what to keep in the open source.
You asked about the governance model around Ray. So Ray, of course, we do a ton of Ray development at Anyscale. We collaborate very closely with a number of companies who are all, developing or contributing to Ray. And that's something we've had a really productive collaboration there. The way this works, we have a group of committers, like Ray committers. There's people at Anyscale, people at other companies. And of course, we are regularly adding new committers. This is done based on discussion among existing committers, and it's essentially based on the contributions that the person has made to the project. And that's worked super well so far. I think one of the important things here is just being very communicative with the community and sharing proposals, soliciting proposals, getting feedback on design docs and things like that. And that's been working very well for us so far.
As far as the roadmap for the Ray project, I'm wondering what you see as being the main driving factors as to where Anyscale and the broader community focuses their efforts, and what you see as being some of the major areas for improvement and areas that could use a bit of additional polish to make the overall Ray experience more accessible and productive for everybody.
There's always a lot of room for improvement. And I like the way you phrased it because, when we think about the value that we're adding, a lot of it is around developer productivity. It's taking away a lot of the kind of low level infrastructure work or systems work and letting people iterate faster at a large scale. And so, the core areas that we want to focus on are really making it easy to scale right from your laptop to the cloud, and making it really easy to move from development to production. And so, of course, these are areas we've been working on for a while, and the production one is especially a large focus right now. I think we see a lot of room for improvement in performance when it comes to, especially at scale. We see a lot of room for improvement in, the serverless experience, right? Making it so that developers don't have to think about clusters, don't have to configure clusters or instance types, that they can just, as much as possible, just focus on their application logic. So that's something we're really trying to double down on.
One of the other things that's interesting to cover is maybe the ways that you think about engagement with the broader community and how the ecosystem has developed as to sort of which pieces should integrate closely with Ray and which ways Ray should kind of meet the rest of the community where it's at.
Over time, people and the industry will converge on a tech stack for AI. And right now that's pretty wide open. But we see Ray emerging as the compute layer for that stack. And of course, there are many pieces to this stack, right? There's everything from, the data component to the model registries and feature stores, experiment tracking. And so I think all of these components of this eventual stack should integrate together. And of course, we want it to be really seamless for our users. If your data is stored somewhere, and whether it's Databricks or Snowflake, and then you're doing training or serving with Ray, it's critical to have seamless integrations there. Similarly with integrate with experiment tracking tools like weights and biases or ML flow. One of the things that people like about Ray, I mentioned you can run Ray anywhere, but Ray is also super framework agnostic. You can use it with any other tools out there, right? Certainly with any Python libraries or deep learning frameworks like PyTorch and TensorFlow or scikit-learn, it's very compatible with what you're trying to do. So I don't know if there's any of these tools in the space, where we don't think there could be a good integration story.
And I know that the last time we talked, towards the end of the conversation, I was asking about the language ecosystem aspect of Ray, where initially it was very focused on Python because of the strong focus of the Python community on machine learning and AI. And I was asking about the capabilities of Ray to be able to support some of the other language runtimes. And I know that you had said that there was at least some initial goals of being able to do that. So I'm curious what the current state of affairs is with regard to being able to use Ray for scaling compute across other language runtimes.
Things may not have changed there so much since the last time we chatted. We were very focused on Python as, the main use case where we're trying to make it super successful. That said, people also use Ray to scale Java, and, supporting a couple different languages like that has made us, in a good way, forced us to design the whole system in a pretty language agnostic way, right? So that eventually you'll be able to, use Ray to scale computation in many different languages. There's a little bit of work right now happening on Rust, scaling Rust, but by far the majority of work is on Python. And of course, part of Ray is written in Python, but a lot of Ray is written in C++, and that turns out to be a pretty good combination for building performance systems.
In your experience of working with the Ray community, building the framework, building the business around it, and helping to grow that ecosystem, what are some of the most interesting or innovative or unexpected ways that you've seen Ray or Anyscale used?
This isn't entirely unexpected, but one of the things that has been great to see is seeing more and more organizations either evaluating reinforcement learning for their use cases or actually, really succeeding with reinforcement learning in ways that, they wouldn't have been able to do without reinforcement learning. We've seen that certainly in gaming, in recommendations, starting to see that as well in like industrial applications and then potentially medical applications. So there's a lot of promise there. I think that's one of the main unexpected things. I think we're always surprised by just how broadly machine learning can be used in just every industry and across, every different use case.
In your own experience of building the Ray framework and growing the Anyscale business around that, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
For building the business, it's been exciting. My background is more on the engineering side, right? Like actually doing the software engineering to build Ray and things like that. I gravitate toward APIs, the user experience. And, one of the things that I really care about is just how can we create a magical experience for developers. That said, in addition to the engineering side and thinking about the product, there are many different aspects to running a business, many of which are things that I had essentially no exposure to beforehand. And so everything's surprising to me. I've certainly been learning a lot along with my co-founders. Had a really fantastic time doing this.
For anybody who is looking to accelerate or scale their adoption of machine learning and AI, what are the cases where Anyscale or Ray are the wrong choice and they might be better suited with a different execution framework or a different operating environment or just some homegrown capabilities?
Good question. I think, for scaling AI, that really is, our bread and butter, like where we are strong. One thing we don't do, for instance, is more on the data side, like whether that is, large-scale SQL queries or other kinds of data analytics like that. The extent to which we do data processing in Ray, it's really targeted at the data processing you need in order to do training and other parts of the machine learning lifecycle. So there are many, data scientists whose use cases would not be a good fit for Ray or Anyscale. But when it comes to, deep learning or the compute behind training or the experimentation or, the deployments, those are all things where I think, Ray and Anyscale are a pretty good choice.
As you continue to grow the business and the technology stack around Anyscale and Ray, what are some of the things you have planned for the near to medium term or any projects or initiatives that you're excited to dig into?
I would say for Ray, one of the things we're super excited about is just building a great library ecosystem on top of Ray. And there's sort of two components to that, right? There's having best-in-class libraries so that the best way to do training or the best way to do reinforcement learning or serving is to use a library on top of Ray. And then there's also the component of making sure these things work seamlessly together, right? It's not just a collection of libraries, but really a coherent ecosystem, a coherent, seamless experience for users. So that's something we're excited about with Ray. With Anyscale, it's really about, this serverless experience, making it so that you just don't think about configuring clusters. As a developer, you just focus on the application logic and everything else just works out. If you need more resources, you have them. If you don't need them, they go away. That's true for any, type of accelerator or memory or compute, CPUs, GPUs. And like the kind of experience you want to have is like, if you know how to program on your laptop, then you could take advantage of all the benefits of the cloud without becoming an expert.
Are there any other aspects of the Ray project and its ecosystem and the work that you're doing at Anyscale or just the overall space of being able to adopt and scale artificial intelligence and machine learning applications that we didn't discuss yet that you would like to cover before we close out the show?
I would say one thing that I could say a little bit more about is I'll say a few of the interesting directions we've seen with AI workloads. So one is for serving. We all know about deploying machine learning models and taking your model and putting it behind some endpoint. But the complexity can really increase in a few different scenarios. So one is if you need to scale. Another is if you start to have many models or multiple models that you're composing together. And as an example of, imagine you're trying to deploy a service that reads street signs or something like that. You might want to have a first model that detects where the street signs are, and then a second model that if are some street signs, then the second model like reads the signs, right? And so that's just an example, but when you start, there's a lot of natural scenarios where you want to compose multiple models together. Third case is where your machine learning, it's not just a model, right? It's actually machine learning models combined with other business or application logic, right? And so when these things start to get intermixed, you need more flexibility. And sort of a fourth challenge that a lot of people run into is, doing model serving, but in a very framework agnostic way. So some of your developers are using PyTorch, some of them are using TensorFlow, some are just writing Python code, some are using scikit-learn. How do you have infrastructure that makes all of these things work easily? And these are all challenges that Ray Serve and the serving library on top of Ray is solving, and that we've seen people doing pretty successfully. But I think if there's one direction that is introducing a lot of complexity, but also we see it as a really growing use case, it's the composition of models together to build applications. One thing I'll say about reinforcement learning is that reinforcement learning can be hard to do, and one of the challenges, like when you think about traditional reinforcement learning, you might be thinking about, do I really want to do trial and error in production? Like, that doesn't sound like a good idea. What we've seen is more of a focus on what's called offline reinforcement learning, where essentially you don't have to do trial and error in production. You can actually take data that's been collected, that you've logged from previous interactions, and learn from that and train a reinforcement learning model that's sort of learning from observing what was done in the past. And so this can be safer to deploy, it can be easier to deploy, and it can kind of fit into the existing paradigm for how machine learning models are trained and deployed. So that's something that we think has the potential to make reinforcement learning much more accessible to use and sort of open it up to a lot more applications.
Yeah, definitely interesting considerations, and particularly the composition of models and being able to manage the sort of stages of execution I can see as being very valuable and unlocking a lot of additional applications to machine learning that would be otherwise unwieldy or impractical for organizations to try and adopt.
Yeah, there are many reasons you might want to do it. I mean, one is that you might have a model that's cheaper to evaluate but less accurate, and another model that's more expensive but more accurate. And you may want to do multiple passes to kind of conserve resources but get to the best decision. And so that's something we see all the time. And if you're interested in this model composition stuff or some of the challenges around model deployment, RayServe is the library on top of Ray that's trying to solve these challenges.
Yeah, it's definitely interesting because I can see a number of organizations would likely just try to fit all of the capabilities into a single model and explode the complexity with having a reduced capacity and, degraded overall experience.
And it gets hard. One thing to build the infrastructure yourself when you're deploying one model. And we see that, that's very normal to do. But we have customers that are deploying hundreds of models. Some of them are these, tiny, inexpensive models to evaluate. Some of them have very high memory footprints and are very computationally intensive. And so figuring out how to place these on different machines or how to, scale these in different ways, you end up starting to build a lot of infrastructure. And that's something we simplify a lot.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. This week, I'm going to choose a book that I've been reading with my son called Beyond the Deep Woods. And it's the first book that was written as part of the Edge Chronicles, which is actually a fairly expansive series of stories. But the first one that we've been going through so far has just been a lot of fun, really interesting story, great characters, has a lot of really cool illustrations in it. But it's a chapter book, so it's got a lot of good sort of meat to it. It's a great story to read with, anyone from, upper elementary school up to, ancient adults. I've been having a lot of fun with it, so definitely recommend checking that out if you're looking for something to read. And with that, I'll pass it to you, Robert. What do you have for picks this week?
Two things that come to mind. So one, Ray related, is that at the end of this month, we're having a one-day RL summit on production reinforcement learning. And that's something that you're excited about, interested to see how a wide range of companies are deploying reinforcement learning in production, what that looks like. That's going to highlight a lot of use cases. The other is a science fiction book that I read recently, which I enjoyed a lot, called Project Hail Mary. And it's about, saving the planet from, I guess, extinction.
All right, I'll have to check that one out. Well, thank you very much for taking the time today to join me and share the work that you've been doing at Anyscale and on the Ray project and ecosystem. It's definitely a very interesting and valuable project and capabilities that you're offering to people for being able to support their machine learning and AI capacities. So appreciate all of the time and energy that you and your team have put into that, and I hope you enjoy the rest of your day.
Thanks so much.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.